Okay, welcome to Math 60. These are the lesson video notes that I would encourage you to watch at home and take detailed notes. The outlines are available at Desire to Learn. We're going to start in Chapter 1, Section 1, so 1.1. We're going to be dealing with some vocabulary and talking about some introductory items for algebra. In this particular section, we're going to talk about variables and mathematical models. Hopefully some of the information in Chapter 1 will be review for you. It does cover a little bit of some things that should be coming from Math 20 or some skills you should have coming into Math 60. If any of these items are causing you extra trouble, please get help right away. See me in class or the syllabus for some ideas of how to do that, or during my office hours, club hours as we're calling them. Okay, so let's get started here. Let's look at some vocabulary. A variable is. What is a variable? Well, in terms of mathematics, a variable is going to be a letter. In terms of life, a variable is something that can change. And in that case, that's what we're doing here in algebra, is we're allowing a number to change its value. And so we don't know it yet, therefore we'll represent it with a letter. Typically, the letter that you see used is x, so a variable is a letter like x, and it can be any number. Now, where all the math people hang out, there can be some quite heated discussions about whether you can call particular letters in algebra variables or just unknowns. For our purposes and for this book, anytime we have a number that is hidden, or it's a mystery number, or it's a variable it can change, or it's an answer we don't know yet, we'll call that a variable. We'll use a letter to represent a number that we don't know yet. But it can be any letter, anything. It could be X, it could be Y, it could be C, it could be F, it could be W. It can be any letter. Why would we have different letters? Well, we're going to learn as we go through Math 60 and 65 that sometimes you need more than one letter in a particular situation because you don't know, there's more than one number that you don't know. There also might be a reason to use other letters so that you can keep track of what you're trying to find out. For instance, W might be the weight of something that you're trying to figure out. Or F might be the flight speed that you're trying to figure out. C might be the number of children who have purchased tickets for a particular production. So there's lots of flexibility here. Just know that these represent unknown numbers at this point. So our next vocabulary here is an expression. Very important that you begin to really understand the difference between an expression and an equation, which is coming up in a minute. Basically, an expression is anything involving letters and numbers, but there's no equal sign. That's the down and dirty way of describing it, just the quick definition. But to be more specific, an expression is any combination of letters and or numbers using plus, minus, times, division, all the operations, okay, any of those. Whether they actually use these symbols or maybe a fraction bar for division or parentheses for multiplication, any of those that are used to hold it together. And I'll go ahead and do that. That's not a mathematical term per se, but it helps us understand what we're talking about. Operations that are used to connect different terms, and we'll use that vocabulary quite a bit as well. So what's an example of an expression? So something like 3x, which means 3 times x, or maybe 3x minus 5, 3 times x minus 5. Y squared plus 9. We're taking y times itself and then adding 9. Maybe even a more sophisticated one, I'll do it over here, 2x plus 5y, the whole thing over 3, okay, which means division. So any of those would be examples of what an expression is. Sometimes we're given an expression and we're asked to substitute. So we need to look at what substitution is. Substitution is when we're going to, just like it sounds, substitute. We're going to replace something with another. We're used to seeing the letter in there, now we're going to try a number in its place. So substitution is replacing a letter with a given value. You're going to get practice where you're going to be given an expression and then given a value to plug in. You will also be using substitution when you're trying to check your own work. You come up with a solution, you come up with what you think the variable should equal, you'll take that answer, plug it back into the original. That's an act of substitution. And see if you've come up with an answer that makes sense, that makes the equation true. So let's look at an example of what substitution would look like. If we substitute, or the word you might hear is evaluate, x equals 2 in 3x. So we take this expression from up here, 3x, and now we're going to replace the x with a 2. What that looks like is it becomes 3 times whatever that x equals, and you're going to put a 2 in there instead of the x. Now, I really am a promoter of using different colors. The reason why is because I'm a very visual learner. One of the things I'll stress to you this term is to come up, really investigate what kind of learner, what kind of student you are, how you best learn. So if you're a very visual person like me, it might help you to switch pen colors or go back and forth from pen and pencil so that your eyes can go back and read through your problems and your notes and track what happened. So right here we see that we're substituting 2 in for 3x. What changed is instead of the x, there's now a 2 here, 3 times 2. And then we would evaluate that. So what we did, that is the substitution where it replaces. To evaluate that would be to go ahead and figure out what that equals. And 3 times 2 equals 6. So just throwing in a little bit of extra vocabulary there for you. Our next vocab is an equation. And I said it's very important that you figure out the difference between expression and equation. An expression, letters or numbers, being held together with basic operations, so you've got different terms there, but there's no equal sign. An equation, there's always an equal sign. Okay. So an equation is an expression that is set equal to another expression. And that expression could be simple as just a single number. Or it could be a whole nother set of variables and letters and numbers held together with operations. So let's look at what we've got for an example there. So an equation always has the equal sign. That's very critical. Here's an example. The expression 3x minus 5 from up here. That's an expression. As soon as we put the equals 7, we have an equation. That equal sign changes things. Another example of an equation, and this is an expression equal to a number, but an equation could also be an expression equal to another expression. So it could look like this, and this looks a little bit more complicated, but it's still an equation. 9 over x equals 3 times the quantity x plus 1, using some real official terms there to demonstrate verbally that I've got parentheses going on there. 3 times this entire quantity, x plus 1. 3 times, or parentheses, x plus 1. End of parentheses. And then let's talk about what a solution is. So when we're substituting, we're replacing. When we're evaluating, we're coming up with what that replacement would equal then. A solution is a way to undo the equation that we're looking at and come up with what the value of the variable is that's going to make that true. So a solution is the value, and I'm going to put values because sometimes you might get more than one answer. Not a lot in Math 60. That's a Math 65 issue, but I just want to plant the seed for you. It's the value or values of the variable. That makes the equation true. Those of us who have had prior algebra experience, sometimes we get stuck in that mode of thinking there's only one answer to when we have to solve something. And in fact, a lot of math is like that. There's one answer, there's one solution when you solve the equation. But there are situations, we'll run into them at the end of Math 60 when we start talking about linear equations, there's more than one solution. There's more than one value of the variable that makes it true. And in 65, we will see some real benefits of understanding that. So solving is the process of going from the variable being unknown, okay, so it's an unknown at this point when it's a variable, an unknown value, to the process of coming up with the solution, knowing what it is. So I just want to note that here, solving an equation is the process of going from the variable being unknown sorry, I'm getting, didn't quite leave myself enough space to do this. So the process of going from the variable being unknown to known. That's what solving is. You end up with some sort of value for the letter. Instead of the variable or the letter, you now have a number. Okay, and that should take care of the top part of page 1, and you'll move on to the next video now for the bottom part of the page. See you there.